Professor, thank you for taking some time to review my attempt at this problem. Without taking any more of your time, let's begin. The combustion analysis of an unknown hydrocarbon is carried out by burning 18.5 grams of the unknown molecule in the presence of excess oxygen to produce 60.963 grams of carbon dioxide and 16.637 grams of water vapor, which is just pretty much water. I don't know why. Excess. Separately, the unknown molecule is analyzed by a mass spectrometer, and the molar mass is found to be 80.13 grams per mole. Determine the empirical and molecular formulas based on this data. Be sure to show your work and explain your problem solving process. To begin, we will start by finding the number of moles of carbon. This is the same as the number of carbon dioxide, because there is only one carbon atom in carbon dioxide. So to figure out the number of moles, it's the mass divided by the molar mass. And in the case of carbon, we're going to get a 60.963, which is given to us in the problem, and divided by the molar mass, which can be found by referencing the periodic table. In this case, it'll be 12.001 plus 15 times 2, which is 44.09. And in dividing this, we get 1.385 moles of carbon. We can do this as well. We do this again for hydrogen. And in hydrogen's case, we get 16.637, which is found in the story problem once again. And we divide it by 18.015, which is found by referencing the periodic table once again. 1.008 times 2 plus 15.999. And this is done 2 times because there's 2 hydrogen atoms in this. So after dividing, we get 1.847 moles of hydrogen. And we now need to find the number of moles of oxygen. It was given to us in grams. So in order to find the moles of oxygen, we need to figure out the mass of carbon and hydrogen. This is equal to the number of moles times the molar mass of an atom. So in this case, we'll take the 1.385 that we found and multiply it by the molar mass, which is 12.011 for carbon. And we get 16.634 grams. We'll do this for hydrogen as well. So we'll take the 1.847 and multiply it by 1.008 in order to get 1.867 grams. So then the mass of oxygen is found by taking the 18.5 grams from the problem and subtracting it by the masses that we have found for carbon and hydrogen, and getting 0.01 grams, and then finding the moles by dividing the mass by the molar mass in order to get 0.000625. We then continue by